So the irony in these systems is that the irony in predictive systems is that they're actually unpredictable, at least at first. When machine learning systems are new, they're often inaccurate, which is actually not what we expect from our things. 60 or 70% accuracy is actually really good for a first pass of a machine learning system. But even 90% accuracy isn't enough to make a predictive system feel right, because it's making decisions all the time. It's going to be making mistakes all the time. It's fine if your house is a couple of degrees cooler than you'd like, or warmer, or whatever. But if your wheelchair refuses to go to a drinking fountain that's next to a door because it's been trained on doors, and it can't tell that what you're saying is, I want to go to that thing next to the door, not to the door, that's a real problem. For all the times the system gets things right, you judge it on its mistakes. And mistakes create anxiety. And anxiety is an incredibly heavy kind of cognitive load to bear. And a little doubt about whether a supposedly smart system is going to do the right thing is enough to turn a user experience that's right most of the time into one that's more trouble than it's worth. The last issue comes as a result of these previous two: control. How do we maintain some level of control over these devices when their behavior is by definition statistical and unpredictable? On the one hand, you can mangle your device's predictive behavior by giving it too much data. I visited Nest one time in their early days, and they told me that none of the Nests in their office actually worked because they were constantly fiddling with them. They're constantly playing around with it. And in machine learning, this is what's called overtraining. On the other hand, if I have no direct way to control it other than through my own behavior, how do I adjust it? So Amazon and Netflix's recommendation systems, which are machine learning systems for predicting what you might like, they've been around for a long time. They give you some context about why they recommended something, why they're doing something. But what if my only interface is a garden hose? What do I do? How do I get it to stop spraying water? As interesting as these issues are, I actually think that most importantly, what they represent is that we're entering into a new relationship with our device ecosystem. We're experiencing a sea change in our relationship to the built world. So think of a sewing machine. It's really complex, but it basically acts in response to us. Computers acting autonomously erode this simple tool-user relationship. At the dawn of computing in the late 1940s, cyberneticists like Norbert Wiener philosophized about this increasingly complex relationship between people and computers, and how it was fundamentally different than the way that we've interacted with other kinds of machines and other kinds of tools. So developers who are working in supervisory control of manufacturing machines, so basically, things that build cars, things that are the giant robots in factories, they've actually been having to deal with these questions very pragmatically for a very long time. Now, thanks to the Internet of Things, it's actually everybody's problem. So this is a diagram by the greats Tom Sheridan, who was a brilliant engineer, and Bill Verplank. This is from 1978, in which what they're trying to do is they're trying to illustrate 4 ways that semi-autonomous computers and humans can work together to solve a problem. This actually comes out of an amazing project when they were, in the freaking 70s, they were doing these semi-autonomous submersible robots that would go deep underwater, and they were so deep underwater that you'd have to control them from the surface, but you didn't have really great control. You just have to tell them what to do, and they'd have, 1975, they were doing this. Sheridan continued to think about this, because he's a smart guy. By 2000, he'd actually expanded that idea to create this framework and to define a spectrum of responsibility between people and computers. So it ranges from the top, number 1. So I'll read it for the folks in back. The computer offers no assistance. Humans must make all decisions and actions. So it ranges from 1, where humans do all the work. That's like, you writing an essay, unless you're in school, in which case you Google for it, or you knitting, to 10, computers doing all the work. The computer decides everything and acts autonomously, ignoring the human. That is your car's fuel injection controller. So, of course, the goal is to get something now down here near 9 or 10. And that's kind of the maximum reduction on cognitive load. But for a system to qualify for that, it needs to be very stable. Its effects need to be very predictable. And more importantly, its role needs to be very well embedded and understood in society. We trust it to do that thing. At the airport, we trust the monorail computer to work without human intervention. But we don't trust the plane autopilot to do that, even though, as I understand it, planes can basically fly themselves these days. It's not socially embedded yet. Predictive IoT devices generally fall between 5 and 7 today, and probably for the near future. The problem is that this is the exact range where you're maximizing someone's cognitive load because you're making them make a lot of decisions, but not necessarily doing all the work for them. So the result of the automation had really better be worth it in order for that system to work. Moreover, that relationship fundamentally undermines what we expect from our tools, because when that tool is trying to anticipate what we're trying to do and try to get in front of us in doing it, it fundamentally changes our working relationship with it.